H by negative B over 2A. You solve for K by the f of H is negative B over 2A. So to find H in the beginning, you go to your normal formula, which is 9.2A squared minus 19A plus 20. So to find the H, you do negative of negative 19 divided by 2 times 9.2. And when this comes out, it's a positive 19 divided by this, which gives you 1.03. And to solve the K, you put 1.03 in for the f of, and then you solve it out, which is 9.2 times 1.03 squared minus 19 times 1.03 plus 20. And when you do that, you get 9.2 times, when you square this, you get 1.0609, minus, when you times these two together, you get 19.57, still plus your 20. Then you times these two together, which gives you 9.76028 minus 19.57 plus 20. And when you add all them together, you get 10.19. So your vertex in this situation is 1.03 and 10.9. So you come over to your graph here, and when you graph it, you start out at your vertex point, which is, like we said, 1.03 and 10.19. Your y-intercept, Jeff will tell you about that.
Our y-intercept is where the line crosses on the y-axis, which was 0, 20. Our domain, which is all our points, and it exceeds the graph. So we decided it was negative infinity to positive infinity. And the range, which is the lowest point on the parabola, we had it as 10.19 to positive infinity. And there were no zeros because nothing crossed our x-axis.
The last part of the problem, they wanted to find out how much antibiotics would be needed for 45 million of fungi. So here we use the quadratic formula for this, but you have to set it up. You put 45 million in for your f of A, and then so you subtract 45 here, which would give you 9.2A squared minus 19A minus 25. So you plug all that into your quadratic formula, which would give you x equals minus the minus of 19 plus or minus the square root of 19 squared minus 4 times 9.2 times 25 over 2 times your A, which is 9.2. So right here you get x equals 19 plus or minus the square root of 361 plus 920 over 18.4. So you come over here, and after you take the square root, it approximately is 35.79. So you plug that in, and it's 19 plus 35.79 over 18.4, which you got from times and 2 times 9.2, and it came out to be 2.98 amount of the antibiotics would be needed for 45 million of fungi. But if you come back over here to the graph, when it's grafted, and not 2.98 is right here, and see this up here, 2.98 and 45, which would be up here, right here. This shows that when you have that much antibiotic, the fungi became immune to the antibiotic. Over here, the antibiotic was working to fight the fungi right over here. But after down here coming to your vertex and coming up here, the fungi became immune to the antibiotic, so the fungi remained in your system, and the antibiotics were not working to fight off the fungi.